Isaac Newton, the mind that remade the universe. In the annals of science, one name stands as a titan, a figure whose discoveries fundamentally altered humanity's understanding of the cosmos, Isaac Newton. A reclusive and often difficult genius, Newton's work as a physicist and mathematician laid the groundwork for modern science, ushering in an age of reason and discovery. His insights into gravity, motion, light, and mathematics were not just incremental steps forward, they were revolutionary leaps that reshaped the very fabric of knowledge. Born prematurely in a small English village in 1642, the same year Galileo Galilei died, it was as if the torch of scientific inquiry was passed from one giant to another. Newton's life was one of relentless intellectual pursuit, driven by an insatiable curiosity to decipher the laws that govern existence. This article explores the 10 pivotal achievements of a man whose mind journeyed to the farthest reaches of the universe without ever leaving his study, a man who, in his own humble words, saw further by standing on the shoulders of giants. 1. The Annus Mirabilis, a plague-fueled year of genius history, is filled with tales of remarkable productivity, but few can rival Isaac Newton's Annus Mirabilis, or Year of Wonders, from 1665 to 1666. When the Great Plague swept through England, Cambridge University was forced to close its doors, sending the 23-year-old Newton back to his family home at Woolsthorpe Manor. For the next 18 months, in relative isolation, Newton's mind exploded with a series of groundbreaking ideas that would form the bedrock of his life's work. It was during this intensely creative period that he laid the foundations for 3 distinct and revolutionary fields of study. First, he developed the fundamental principles of what would become differential and integral calculus, a new and powerful mathematical language for describing change and motion. Second, he began his revolutionary experiments with light and prisms, discovering that white light is not pure but is instead a composite of all the colors of the rainbow. This insight would lead to a complete overhaul of the science of optics. Finally, and most famously, it was during this period that Newton began to formulate his universal law of gravitation. The apocryphal story of the falling apple, while likely an embellishment, captures the essence of his breakthrough. The realization that the same force that pulls an apple to the ground might also be the force that holds the moon in its orbit around the Earth. This single, plague-enforced retreat from university life produced a torrent of genius that would set the course for the next 2 centuries of scientific discovery. 2. The laws of motion, writing the rules of the physical world. If the universe is a grand stage, then Isaac Newton provided the script that all objects on it must follow. In his monumental work, the Principia Mathematica, Newton laid out his 3 fundamental laws of motion, which have become the cornerstone of classical mechanics. These laws describe the relationship between an object and the forces acting upon it, and they provide a complete framework for understanding the motion of everything, from a thrown baseball to the planets in their orbits. The first law, the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This was a direct challenge to the old Aristotelian idea that objects needed a continuous push to keep moving. The second law provides a quantitative description of force, defining it as the product of an object's mass and its acceleration. This elegant equation is one of the most important in all of physics, allowing us to calculate the precise effect a force will have on an object. The third law is the famous principle of action and reaction. For every action, there is an equal and opposite reaction. This means that forces always occur in pairs. When you push on a wall, the wall pushes back on you with equal force. Together, these 3 laws created a deterministic and predictable model of the physical world, transforming physics from a descriptive discipline into a precise, predictive science. 3. Universal gravitation, the force that binds the cosmos. Newton's law of universal gravitation is arguably his most celebrated discovery. It was a revolutionary idea that unified the heavens and the earth under a single, elegant mathematical principle. Before Newton, the celestial and terrestrial realms were seen as separate, governed by different rules. Newton's great insight was that the force of gravity is universal. It applies to all objects with mass everywhere in the universe. The law states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This inverse square law was the key that unlocked the secrets of celestial mechanics. It explained why planets move in elliptical orbits, as Johannes Kepler had observed. It accounted for the tides, the precession of the equinoxes, and the motion of comets. The famous story of a falling apple at Woolsthorpe Manor prompting this thought is likely simplified, but it perfectly illustrates the core concept. The same force that causes the apple's downward acceleration also keeps the moon in a perpetual state of falling around the Earth. By providing a mathematical description of gravity, Newton gave humanity the tools to understand and predict the grand clockwork of the solar system. 4. Philosophiae Naturalis, Principia Mathematica, the book that changed science. Published in 1687, Isaac Newton's Philosophiae Naturalis Principia Mathematica, Latin for Mathematical Principles of Natural Philosophy, often referred to simply as the Principia, is widely considered to be the most important scientific book ever written. This 3-volume work is the culmination of Newton's discoveries in mechanics and gravitation. It is not an easy read. The Principia is a dense and rigorous work, written in Latin and filled with complex geometric proofs. However, its impact was profound and immediate. In the Principia, Newton systematically lays out his laws of motion and the law of universal gravitation. He then applies these principles to provide a complete mathematical explanation for the workings of the solar system. He derives Kepler's laws of planetary motion from his own more fundamental principles, explains the paths of comets, and provides a quantitative theory for the tides. The book was a stunning demonstration of the power of mathematics to describe the natural world. It established the foundation for classical mechanics and dominated scientific thought for the next 200 years, until the emergence of Einstein's theory of relativity. The Principia did more than just present new discoveries. It presented a new way of doing science, one based on mathematical laws, empirical evidence, and testable predictions. 5. The invention of calculus, a new language for a dynamic world. Mathematics before Newton was largely equipped to deal with static, unchanging quantities, but the world is in constant flux. To describe things like the velocity of a falling object, the curve of a planetary orbit, or the changing slope of a line, a new form of mathematics was needed. Isaac Newton provided it by inventing calculus. During his year of wonders, he developed what he called the method of fluxions, a powerful tool for analyzing rates of change, differential calculus, and accumulating quantities, integral calculus. Calculus gave scientists and mathematicians a language to describe motion and change with unprecedented precision. It is the mathematical engine that drives much of modern science and engineering. While Newton developed his version of calculus in the 1660s, he was notoriously secretive and did not publish his work for decades. This led to a bitter and prolonged dispute with the German mathematician Gottfried Wilhelm Leibniz, who independently developed his own version of calculus around the same time. While the controversy over who deserved credit was fierce, historians now recognize that both men invented calculus independently. However, it was Newton who first applied this powerful new tool to solve major problems in physics, demonstrating its immense utility and cementing its place as one of the most important mathematical developments in history. Wasserschenwast 6. Deconstructing the rainbow, unraveling the mysteries of light and optics. Before Isaac Newton, the prevailing theory of colour, dating back to Aristotle, was that colour was a modification of white light. It was believed that a prism, for example, somehow stained the white light passing through it to create the colours of the rainbow. Newton, through a series of ingenious and elegant experiments, proved this to be wrong. His work in optics was as revolutionary as his work in mechanics. In a darkened room, Newton allowed a thin beam of sunlight to pass through a prism. The prism refracted the light, casting a spectrum of colours: red, orange, yellow, green, blue, indigo, and violet onto the opposite wall. This was a well-known phenomenon, but Newton took it a step further. He used a second prism to try and split one of the colours, say green, even further. He found that it could not be done. The green light remained green. In a brilliant final step, he used a second, inverted prism to recombine the full spectrum of colours, and he found that they merged back into pure white light. This experiment conclusively demonstrated that white light is not a single entity, but is, in fact, a mixture of all the colours of the spectrum. This discovery laid the foundation for the modern science of optics and our understanding of light. 7. The reflecting telescope, a new window to the heavens. Newton's discoveries in optics had practical applications as well. At the time, the dominant telescope design was the refracting telescope, which used lenses to bend and focus light. However, these early telescopes suffered from a significant problem known as chromatic aberration. Because a simple lens bends different colors of light at slightly different angles, bright objects viewed through the telescope were often surrounded by a fuzzy, colored halo, which limited the instrument's clarity and power. Armed with his new understanding that white light is a composite of different colors, Newton realized that this problem was fundamental to any telescope that used simple lenses. To solve it, he designed and built a completely new type of telescope, the reflecting telescope. Instead of using a lens to gather light, his design used a curved mirror. Since a mirror reflects all colors of light at the same angle, it completely eliminates the problem of chromatic aberration. In 1668, he constructed the first functional reflecting telescope, a small but powerful instrument that produced clearer and sharper images than the much larger refracting telescopes of his day. This design, now known as the Newtonian telescope, was a major advance in astronomical instrumentation and remains a popular design for amateur and professional telescopes to this day. 8. Master of the Mint, a surprising career in public service. While we remember Newton primarily as a scientist, he spent the latter half of his life in a very different role, as a prominent public official in London. In 1696, he was appointed Warden of the Royal Mint, and 3 years later, he was promoted to the more prestigious position of Master of the Mint, a post he held until his death in 1727. This was no mere ceremonial role. At the time, England's currency was in a state of crisis. Widespread clipping, shaving off small amounts of precious metal from the edges of coins, and counterfeiting had devalued the currency and threatened to destabilize the economy. Newton attacked this problem with the same methodical rigor and intensity that he applied to his scientific work. He oversaw a massive project to recall all of the old, damaged currency and replace it with new, more secure coins with milled edges, making clipping impossible. He personally went undercover in taverns and alehouses to gather evidence against counterfeiters, acting as a relentless detective and prosecutor. He successfully prosecuted dozens of criminals, including the notorious counterfeiting kingpin William Challoner. Under Newton's stewardship, the Royal Mint was transformed into an efficient and modern institution, and England's currency was placed on a stable and secure footing. This lesser-known chapter of his life reveals a practical and fiercely dedicated administrator, a man who applied his genius not just to abstract principles, but to the pressing problems of his nation. 9. President of the Royal Society, a reign over British science. In 1703, Isaac Newton was elected President of the Royal Society of London, the most prestigious scientific institution in Britain. He would be re-elected to this position every year for the rest of his life, a reign of 24 years. As president, Newton wielded immense power and influence over the direction of British science. He used his position to promote his own scientific ideas and to ensure that his legacy was properly recognized. Under his leadership, the Royal Society flourished, moving to a new, more permanent home and increasing its prominence on the world stage. However, Newton's presidency was not without controversy. He was an autocratic and often ruthless leader, known for his vindictive pursuit of his rivals. His long and bitter priority dispute with Gottfried Wilhelm Leibniz over the invention of calculus is a prime example. Newton used his position as president to stack a Royal Society committee with his own supporters, which then issued a report declaring that Newton was the true inventor and accusing Leibniz of plagiarism. He also engaged in a fierce feud with the astronomer John Flamsteed, the Astronomer Royal, at one point seizing Flamsteed's star catalogue and attempting to publish it without his permission. While his leadership was undeniably impactful, this period also showcases the more difficult and authoritarian side of Newton's complex personality. 10. The enduring legacy, from classical mechanics to the Enlightenment. Isaac Newton's impact on the world is difficult to overstate. His work marked the climax of the scientific revolution and provided the intellectual foundation for the Enlightenment, the 18th century philosophical movement that emphasized reason, individualism, and skepticism. Newton demonstrated that the universe was not a mysterious and unpredictable place governed by the whims of divine beings, but a rational and orderly system that could be understood through observation, mathematics, and human reason. This mechanical, clockwork view of the universe had a profound influence on the thinking of philosophers like John Locke and Voltaire, who sought to apply similar principles of reason to human society, government, and morality. His scientific laws remained the bedrock of physics for over 2 centuries, and they are still used today to calculate everything from the trajectory of a spacecraft to the stresses on a bridge. The mathematical tools he invented are indispensable in countless fields of science and engineering, but perhaps his greatest legacy is the paradigm shift he created. Newton gave humanity a new confidence in its ability to understand and master the natural world. He proved that the universe was governed by universal, discoverable laws, a revelation that not only remade science, but also forever changed humanity's place within the cosmos.